Lotus Elan 1500. Lotus Elan 1500, 1600, S2, S3, S4, Sprint. Production 1962 to 1973. Assembly, Cheshunt, England. Hethel, England. Designer, Ron Hickman. Body and chassis. Body style, 2-door coupe, 2-door roadster. Front engine, rear-wheel drive. 1498 cc later 1558 cc Lotus Twin Cam i4, petrol. Transmission, 4-speed manual, all synchromesh. Dimensions. Wheelbase, 84.0 in, 2134 mm. Length 145.0 in, 3683 mm. Width 56.0 in, 1422 mm. Height 45.5 in, 1156 mm. Curb weight, approximately 1,500 pounds, 680 kilograms. The Lotus Elan was the first Lotus road car to use a steel backbone chassis with a fiberglass body. This style of construction was to be repeated in subsequent Lotus models for nearly 3 decades. At approximately 1,500 pounds, 680 kilograms, the Elan embodied Colin Chapman's minimum weight design philosophy. The Elan was technologically advanced with a DOHC 1558 cc engine, 4-wheel disc brakes, rack and pinion steering, and 4-wheel independent suspension. Gordon Murray, designer of the McLaren F1 supercar, reportedly said that his only disappointment with the McLaren F1 was that he could not give it the perfect steering of the Lotus Elan. In 2004, Sports Car International named the Elan number 6 on the list of top sports cars of the 1960s. The original version of the car was designed by Ron Hickman. An optional hardtop was also offered. The Elan 1600 of 1963 was replaced by the Elan S2 in 1964. In 1965 the Type 36, a fixed-head coupe version of the car, was introduced, while in 1966 the drop-head coupe Type 26 was replaced by the Type 45. Both types, 36 and 45, were offered initially in S3 form, followed in 1968 in S4 form, and finally in 1970 as the Elan Sprint. Production of the Sprint ceased in 1973. The standard S2, S3 and S4 models were also available in a slightly more powerful and luxurious, special equipment, variant, generally referred to as the Shay. Lotus Elan S3 Shay. In the UK the Elan was offered as a fully assembled vehicle and, for tax avoidance purposes, as a lower-cost kit for final assembly by the customer. The basic structure of the Lotus Elan comprised a fabricated mild steel backbone chassis, similar to a double-ended tuning fork, and a fiberglass body. The chassis was the primary stressed component, providing the necessary bending and torsional rigidity. The fiberglass body was solidly bolted to the chassis at 16 points, fitting over it like a saddle. While not highly stressed, the body nevertheless added to the overall rigidity of the structure. As such, the chassis should more properly be considered a subframe. It is readily changeable, and most Elans on the road today have had a new chassis fitted at some point, either due to accident or decay. The engine and gearbox are located between the front fork arms and the differential between the rear fork arms. The front and rear suspensions attach to the ends of their respective arms. Turrets at the end of the arms hold the suspension springs and dampers. Pre-restoration engine showing Ford bottom end and Lotus head, timing chest, cam cover. This design resulted in lightweight, high rigidity, by contemporary standards, and easy driver, passenger access through wide door openings with low sills. Driver and passenger protection from front and rear impact was acceptable for its time, but side impact protection was minimal. The engine, gearbox and differential were all sourced from Ford UK components. The gearbox was a high-volume unit used widely across the Ford range, Anglia, Cortina, etc. Lotus offered regular and close ratio versions. The differential unit was also sourced from Ford but converted for independent rear suspension use. Contemporary Ford cars used live rear axles. 3 differential ratios were offered at various times during the production life of the vehicle: 3.55, 3.77 and 3.9. Most Elans were fitted with 3.77 differentials. 3.90 differentials, which provided the best acceleration, were often favored by purchasers of early cars, while 3.55 differentials became more common in later cars, especially the more powerful Sprints, to provide more relaxed cruising on newly built highways. Differential, Ford gear case, Lotus rear carrier, Rotoflex drive flange. The final drive used 4 Rotoflex couplings, to connect the differential output shafts to the rear hubs. These rubber donut couplings were widely used at the time for road vehicles. Hillman Imp, Triumph GT6, and racing. Ford GT40, Lotus 21, prior to the availability of constant velocity (CV) joints. In the case of the Elan, which had exceptionally supple rear suspension that allowed significant vertical wheel travel, the deformation of the Rotoflexes in operation resulted in some wind-up of the couplings. This could be readily detected by the driver, especially at takeoff and during gear changes, and was slightly disconcerting when driving an Elan for the first time. In practice, drivers typically adjusted their clutch technique within a few minutes and no longer noticed it. In recent years, the uncertain quality of replacement Rotoflex couplings, combined with the availability of half shafts built with CV joints, has resulted in many Elans being converted from Rotoflex to CV joint drive. Rear hub showing Chapman strut suspension Rotoflex drive coupling. A notable feature of the drivetrain design was its use of standard, mass-produced components in combination with a minimal number of specialized aluminium castings to create a power unit and transmission suitable for a high-performance sports car. The engine head and timing chest converted the Ford Kent pushrod engine into a twin overhead cam engine. The differential rear cover and carrier converted a live axle to independent suspension operation. The rear wheel hubs required for the Chapman strut rear suspension. These 3 items were unique to the Elan, although the engine was subsequently used widely in other vehicles. The 1558 cc Lotus twin cam engine was based on the Ford Kent pre-crossflow 4-cylinder 1498 cc engine, with a Harry Mundy designed 2-valve alloy chain-driven twin cam head. The rights to this design was later purchased by Ford, which renamed it the Lotus Ford Twin Cam. It would go on to be used in a number of Ford and Lotus production and racing models. Lotus reported different power outputs for the twin cam engine during the production of the Elan. Lotus marketing material from the S3 period quoted the Shea variant at 115 bhp, 86 kilowatts, noting high lift cams, carburetor rejetting and a 4-branch exhaust. The final version of the workshop manual revised these numbers, as shown in the following tables. The increased power of the Sprint engine was primarily due to slightly larger inlet valves, so it was named the Big Valve engine. It has been widely reported that the combination of hotter cams, rejecting the carbs and big valves improved performance of the 115 bhp Shea by only 11 bhp. As a marketing exercise to increase sales of the new Sprint model, Chapman saw to it that published bhp figures for existing models be downgraded to increase the apparent improvement in performance.